I'm Madeleine Durkee from Texas A&M University. This is Taylor Hinsdale, also from Texas A&M University. And we're going to talk today about UV fluorescence and how we can relate certain demos with UV fluorescence to biomedical imaging and sensing. So first we'll talk to the kids about light on the visible spectrum and how and the energy of that light and fluorescence. So we'll start with talking about how certain chemicals are fluorescent. And so we're dealing specifically today with UV fluorescence. So we'll start with our red laser and show them that the red laser, which as we've described is lower energy than UV or purple light. The red light does not cause any fluorescence within these chemicals. You can just see kind of a reflection off the bottle, maybe a little bit of transmission. But when we shine our blue light through, which has a little bit in the UV spectrum, you can see some faint fluorescence within the vinegar, a little bit more within the Windex, and some really good fluorescence within the vegetable oil. So all of this stuff, since we're in San Diego, we didn't bring any of this from Texas. All of this was just available at Rite Aid. The only things that we had to bring were the laser pointers. And so there are some other fun household fluorescence items like Vaseline is very fluorescent, Scotch tape is very fluorescent. You can see we have it wrapped around a vial around here somewhere. There's some Scotch tape right here with some fluorescent marker on it. Here's the good one with Scotch tape right there. So another kind of favorite fluorescent demo is having the kids draw on sticky notes with fluorescent markers. And so you can see it works really well with the black light. All we have is the laser pointer today though. On the sticky note there's no fluorescence, but as you pass over where you have the fluorescent marker, you get a nice little glow. And so when we have a big black light, everyone's really excited to see their own personal art glowing in the dark room. And so one of our favorite things that is fluorescent is actually turmeric. So just this spice that is in curry. Almost everyone has it in their cabinet at home. Is also fluorescent. We'll dissolve it in some alcohol, whether it's IPA or ethanol. Today we're using IPA. So another fun fluorescent, you can kind of see it glow sometimes actually when it's on your plate. But turmeric is also pH sensitive, which is a really fun thing that not too many people know about. So we put some Windex in it, which has ammonia, so we're making the solution more basic. You can see a nice absorption change, so a big color change. And so we make this analogy with glucose sensing. So you can use implantable real-time glucose sensors to tell the difference between levels of glucose over time in the blood. And what's great about this is that we can show that it is reversible. So if we add some vinegar, we can change it back to yellow. And so you can see that the different concentrations will make different colors within the vial. And so the favorite part about this demo for a lot of the kids is that they actually get a deliverable out of this demo. So Taylor will show you how to make lava lamps out of this demo. Normally when we have them do it, we'll have them choose whether they want it to be a red lava lamp or a yellow lava lamp. Today we're just going to give you guys a yellow lava lamp, make things easy. And so we have to play with the density a little bit. We want enough water to be able to dissolve the Alka-Seltzer, so we put Alka-Seltzer, just another thing you can buy at the drugstore, into the lava lamp with a little bit of vegetable oil. So we'll use water to kind of play with the density, make sure that the oil will still sink, but that our Alka-Seltzer will dissolve. And so right here you can see you have little bubbles kind of floating in the oil within that solution. We're going to go ahead and drop that Alka-Seltzer in and watch it fizz up, and the bubbles will break up and you have your homemade lava lamp. And so when you have a black light, it's really easy to see the color change, but you'll see this fluorescent green here, and it's a little bit hard to see through because it's a little bit dense, but go ahead and give me that one.
Yeah, I'm just going to put some more in.
Let's see, so you can see the green and then the blue in the bubbles. See if you can see the blue in the bubbles here yet. Yeah, you can see the blue of the vegetable oil in there compared to the green of the turmeric. And so it's just a fun demo where the kids actually get to take something home and understand a lot more about fluorescence and about biomedical sensing and what we do as a biomedical community.
I'm going to announce the winners. The bronze medal goes to the third place winner for Turmeric Trials, Household Fluorescence to Describe Biomedical Sensing from Texas A&M.
Okay.